Chuck,
Yes.
I got a cool explainer.
Uh-oh. You're excited. That doesn't happen normally.
Oh, okay.
So this must be a good one.
Extra good.
Yeah.
Okay, you ready?
What is it?
Okay. You ever see Hollywood searchlights?
Yes.
Okay.
Because they shoot a shaft of light into the air.
As they do.
Right.
Very poetically put.
Yes.
Okay. And in fact,
Which we used to use to spot bombers.
yes. Yes.
And then all of a sudden they were like, well, what are we going to do with all these lights? Now that the war is over, what do we do with these lights?
Let's just shoot them up in the air anyway. Right. And in fact, in 20th Century Fox,
Right.
Now called 20th Century,
Yes.
their fanfare at the beginning are searchlights with the big logo.
Yeah, that was,
Okay.
yeah.
All right. So, have you ever looked at one?
A searchlight?
Yes.
No.
No, not directly in it.
Oh, okay.
Just from the side.
From the distance? Yeah. They're,
You look from the side, and it goes up and up and up, then it stops.
yes.
Have you ever noticed this?
Yeah. Even from a distance, what happens is, because they do it every year for 9/11.
Yes, we do.
Yes.
Yes. What they do is, for people who don't know, on 9/11, in honor of 9/11, because this is New York City, we're here at my office at the Hayden Planetarium. We're now 4 or 5 miles north of Ground Zero. They have 2 huge spotlights.
Yes.
And each go vertically up,
Right.
creating
The ghost of the towers that went down.
Yes,
Right.
yes. And so just as an homage.
As an homage.
To each of the towers.
And so I live in Jersey, and I live pretty much on the river where you can see the installation. And what's cool is there's these 2 shafts of light that go up, but then they disappear into nothing at the very top.
Right. There is a top
There's
to
a
the column of light.
To the column of light.
Right.
Yeah. Which is, kind of wild.
It's kind of wild.
Yeah.
Okay. There's a reason for that.
Oh, really?
There's a physics reason for that.
Oh, okay. I'm interested now.
Okay. Are you ready?
Let's go.
All right.
God hates light.
Stop illuminating them.
Jesus, you see I'm trying to sleep. No.
If I put you 20 miles away on the horizon,
Okay.
and I aimed the beam of light at you,
All right.
you would have no trouble seeing it.
Nope, not at all. Especially a searchlight.
Whereas if I point it straight up and you're down here and you're looking, it has an edge.
That's wild.
Okay, it's just physics. Okay, you ready?
Okay.
Here we go. So, first of all, you only see the beam because there's stuff in the air, pollen, dust, water vapor, that reflects light out of the beam to your sight line.
Okay.
Think about that.
That's right.
This is why the phasers in Star Trek, you always see the side view of the Enterprise sending phasers out front. By the way, I never knew why the phasers weren't parallel to each other. They were at an angle.
yeah, always at an angle.
That was a little weird to me.
Yeah.
But if you're looking at a light beam go sideways, you can't see the light beam because the light beam is going the other direction and it is empty space. They turn on the phasers, it would be nothing for you to see from the side. Unless they get chalk dust.
Right. And pop. Right.
Pop, then you'd see the beam,
see the beam.
because the dust particles are reflecting it back to you out the side of the beam.
Okay.
Okay?
Gotcha.
There's a scene in Star Wars Force Awakens where they have the diabolical Death Star that can kill 8 planets at once or whatever, rather than just one.
Yeah.
Okay? The engine revs up, and it goes, and these like light beams come out, laser power light beams, each aimed for a planet, and it takes out all the planets in this star system. Okay? They show people on each of those planets watching the light come to them.
Right.
No, they would have no idea. They would have no idea it was en route. You cannot anticipate light that is about to kill you because
Gotcha.
it's going the speed of light.
Right.
There's no light ahead of it saying, I'm coming.
You don't get to say, it's coming.
Right.
Right.
Right. Okay. So that's just it's a movie trivia fact.
Little factoid.
All right. So that's why you can see the beam at all. If we were in a total vacuum,
Right.
you would not see anything and searchlights would be pointless.
Interesting.
Okay. By the way, in the desert where there's less water vapor and less pollen, there's still sort of desert dust. And so you can work with desert dust. But if the dust were very calm, then the beam would be hardly visible going up. You'd see the base of the light, but the beam would be very hard to see. All right. There's something called the inverse square law of light. So How bright is a light? If you're twice as far away, it's 1/4 as bright.
Gotcha.
3 times as far away, 1/9 as bright.
Gotcha.
4 times as far away,
1/16.
1/16. Okay. I call this, when I teach this in school, I call this the butter gun experiment.
Butter gun?
Butter gun. The longer story, I don't know if I have time to tell this, is you're hired as a short order cook in a restaurant.
Oh.
And you're buttering the toast to toast it to bring it out.
Okay.
And the management says you're using too much butter.
Okay.
Okay. But you want the toast to be evenly spread with the butter.
Exactly.
All right. If there's not enough butter, you can't. No one wants that.
Dry spots in
you
the
can't
toast.
have dry spots on your toast.
No, exactly.
So this person is clever.
We're not animals.
This person is clever and took Astro 101.
Okay.
And said, I'm going to make a butter gun.
Gotcha.
You squeeze the gun, it melts the butter and sprays it onto the slice of toast.
Okay.
Okay? There it is. Now, let's make the toast twice as far away.
Uh-huh.
The cone of butter spreads.
Right.
Now I can fit 4 slices
Right.
in the beam
Yes.
using the same amount of butter. Okay, each toast has 1/4 the butter, but I'm covering the whole surface.
Right.
Now I put it 3 times as far away. The same squeeze will now cover 9 slices of bread.
Okay.
16 slices of bread. I'm still covering the bread. I'm using less butter. I'm saving the restaurant money. I get a raise. And everybody gets a fully buttered slice of toast.
Butter for everybody.
You get butter. You get butter. So the intensity of the butter is dropping.
Right.
But you're still covering
But you're
the
covering
toast.
it.
Okay.
Right.
Light, the intensity of the light drops, even though there's still light there.
Gotcha.
Now,
I see the butter, but it just don't seem like it. Just seems like it's not as much butter on here.
so this beam is dropping off in intensity as 1/, distance squared
Gotcha.
from the ground,
the ground.
from its source. The light gets twice as high up.
Right.
It's only 1/4 as bright at that point. If you're looking down at it, it's 1/4 as bright, 1/9 as bright, 1/16 as bright, 1/25, 1/36. It's getting dimmer and dimmer and dimmer as it ascends.
Right.
Okay. However, you're not looking directly at the light.
Right.
You're looking at light that reflects back to you from the crap that's in the atmosphere.
Right.
So the light coming back to you also drops off as 1/, distance squared. Combine them, the brightness of the beam drops as 1/, distance to the 4th power.
Holy crap.
Holy crap. So if it's 3 times higher up, that light is 1/9 as bright there, and it's 1/9 of that 1/9 as bright to you on the ground.
Right.
It's 1/81st as bright.
Look at that.
So on the ground, the light is dropping off exponentially. And there's a point where your cone can't detect it.
We can't, right. There's light there. You're just not going to be able to see it.
Correct, because you're relying on the light reflecting off of crap coming back to you. Whereas the person in the beam, it's a simple 1/, it's still getting dimmer and dimmer, of course, but it doesn't have this added effect of having to reflect back to you. So all search beams look like they come to an abrupt stop. It rapidly drops below the detection limit of the rods in your retina.
Wow.
Every beam of light going up will look like it has I have a laser that I use to point out the night sky. It looks like it stops. Yet, if you're 60 miles away, you'll be able to see the laser.
Right.
But from on the ground, it looks like it has an edge. So there you have it.
That is very...
It's not the 1/r² law, it's the 1/r to the 4th.
I love it. Yeah, so now the next time I see the 9/11 memorial, I'll be like, hey! And they'll be like, you're a little too excited for this.
Let me explain. I know why.
Yeah, guess what, guys? They were like, dude, it was a tragedy. Just take it easy.
Let's leave it that way.
Get 2 flashlights and explain.
All right. That's all we got time for in this explainer.
That was good.
From the Star Talkerverse. Neil deGrasse Tyson. Chuck, good to have you.
Always a pleasure.
As always, keep looking up. What would you do if an alien actually showed up? Would you shake its hand or run? Does it even have a hand to shake? In my latest book, Take Me to Your Leader, I explore not only how they might have gotten here, but what they might want and how you should respond. Because the real question is not, are we alone? It's, are we ready? By the way, I also narrated Take Me to Your Leader. And I'm duly informed that you can get a copy of that book or the audiobook now, wherever books are sold. you should probably get the book sooner rather than later. You don't want to have a first alien encounter and not be ready for it. I'm just saying.